So we are into the revision session. EMFT revision session. Well, I'll be discussing about the most important topics from elements of EMF theory that are potentially contenders for the examination. If you have any doubts, you can please ask in the chat box. So let us start the session of EMFT revision. EMFT revision session for GATE 2026. Important topics of elements of EMF theory. So we all know for ECE module 1 and for electrical the complete syllabus is of the topic elements of EMF theory. Elements of EMF theory focus on static and time varying fields. In static field theory, we see electrostatics and magnetostatics. In time varying field theory, we see about time varying electric field and time varying magnetic field. So this electromagnetic field theory is mainly governed by two general laws. What are those two laws? The general laws that govern electromagnetic theory. What are those general laws? Anyone? The generalized law anyone? The generalized law that governs electrostatics is Coulomb's law. And the generalized law that governs magnetostatics is Biot-Savart law. And these are very important for examination. We know Coulomb's law deal with force between point charges and according to Coulomb's law, the force between any two point charges is given by Q1 Q2 by 4 pi epsilon naught r square AR. AR is the direction of force. And we also know that electric field, which is given in Newton per Coulomb, is defined as force per unit charge, is given by Q by 4 pi epsilon naught r square AR. This implies a very important conclusion that electric field E is always along the radial direction. This is one very important conclusion, that the direction of electric field is always along the radial direction. For example, if you consider a positive charge Q, then you know, if I want to find at some distant point R, from this formulae, it will be along AR, it's along R, in this way. Take one more point. It will be in this way. If you take one more point, it will be in this way. If I take one more point, it will be in this way. Clearly indicating that this is R. It is clearly indicating that electric field is always along AR. That is, it is in radially outward direction. And this is a very common diagram that you all know. Potentially, they can ask a question on this. You can expect a question on direction of electric field. If I reverse the polarity, if I take a negative charge, these flux lines now will enter in like this. Indicating that a positive charge acts as source of electric field and the negative charge acts as sink of electric field. Similarly, if I take a line charge, if I consider an infinite line, if I consider an infinite line, carrying current I along it, if I consider some radial distance rho, then electric field at this point will be along a rho. Now, if this line is carrying a line charge rho L, on the counterpart you can give electric field E is rho L by 2 pi epsilon naught rho a rho. Clearly again, electric field is along the radial direction. Similarly, if I consider a sheet of charge If we consider a sheet carrying a charge rho s, uniform surface charge density rho s, electric field at any point will go along the normal direction, indicating that electric field is again radial in nature. It is given by E is rho s by 2 epsilon naught an. Now, if you take such two charges side by side, or two sheet of charges side by side, it acts like a parallel plate capacitor, provided one carries charge rho s, other carries charge minus rho s. Now you have equal and opposite charges separated by some distance, forming a parallel plate capacitor. And this is an normal, this is minus an. Electric field at this, for this parallel plate capacitor, is given by E is equal to E1 plus E2, which is rho s by 2 epsilon naught an plus minus rho s by 2 epsilon naught minus an for the second plate. This is the first plate and this is the second plate, separated by free space having permittivity epsilon naught. And you get total electric field is rho s by epsilon naught an. A very important expression. Electric field for a parallel plate capacitor. This is electric field for a parallel plate capacitor. Okay. And this is also potentially a very important topic. Now, on the counterpart, as you have Coulomb's law here, on the counterpart, we have Biot-Savart law. And according to Biot-Savart law, consider Biot-Savart law. Biot-Savart law is a generalized law that governs magnetostatics. And according to Biot-Savart law, the magnetic field intensity due to a differential current element, in magnetostatics, all the differential current elements are equivalent. Ideal is equal to KDS is equal to JDV. Each of them having a unit of ampere meter. Magnetic field intensity H due to a line current is given by ideal cross R by 4 pi R cube. Surface integral of KDS cross R by 4 pi R cube. Volume integral of JDV cross R by 4 pi R cube. Clearly, as we know, if you take a cross product, A cross B is given by mod A, mod B, sin theta AB into AN. AB sin theta gives you the area formed by the arms of a parallelogram A and B, representing the magnitude of the cross product, and AN represents the direction of the cross product. From this, it is very clear that for any cross product, the direction of the resultant of the cross product is always perpendicular to both the vectors which are involved in the cross product. So if I take a similar case here, then the direction of magnetic field, which is the resultant of this cross product, must be perpendicular to both current and radial direction, giving rise to a very important conclusion that the direction of magnetic field is perpendicular to both current and radial direction. Unlike electric field, if you remember, electric field is always along the radial direction, whereas magnetic field is perpendicular to both current and radial. Now, if I consider it for a finite line, the magnetic field for a finite line is given by H is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1 of A phi. This is for a finite line carrying current I along the z axis. So current is along the z direction, radial is rho, so A rho, AZ cross A rho is A phi. That makes some sense that the magnetic field is along the phi direction, because as we know, the direction of magnetic field is always perpendicular to both current and radial. This for a finite line evaluated at some random point. If I take this for a radial point in the sense the point of evaluation is in between the ends of the line, something like this. Then instead of considering the exterior angle, you consider the interior angle for alpha 1. So minus cos alpha 1 will become plus cos alpha 1. Then if you consider for a finite line, at radial point, then H will be I by 4 pi rho cos alpha 1 plus cos alpha 2 of A phi. This for a radial point. Now, if I consider a semi-infinite line, if I consider a semi-infinite line, for a semi-infinite line, H is given by I by 4 pi rho A phi. For an infinite line, it is 2 times of this, which is I by 2 pi rho a phi. So this is also potentially very, very important topic. Just like we revised Coulomb's law, which is a generalized law that governs electrostatics. This is Biot-Savart law, the generalized law that governs magnetostatics. Equivalently very, very important. Okay. That is the second important topic. And also from module 1, we have a very important topic called forces. This force can be force between two point charges, can be force on a current element, force between two current elements. Now, force on a point charge, I can say force on a point charge rather. Force on a point charge is given by Lorentz force equation. Can anyone elaborate what is Lorentz force equation? What is Lorentz force equation telling you? Anyone? Bhumika, Sharmila, Velraj. Can anyone? Yeah, that is, yeah, that is the force exerted. Lorentz force equation will tell you the force exerted on a point charge in the presence of both electric field and magnetic field. It is actually a combination of electric force and magnetic force. Electric force is given by QE, magnetic force is given by Q into U cross B. As a combination of both, you get Lorentz force equation. Similarly, if you take force on a current element, which can be ideal, KDS or JDV, force on the current element is given by This is the total force exerted on this current element. So basically, this is a magnetic force, which is Q into U cross B. So take the differentiation of this. It is dQ cross B. dQ equivalent is ideal. Ideal cross B. F is line integral of ideal cross B. This is from where you got this. So if this current element is placed in some magnetic field B, then the force exerted is given by line integral of ideal cross B equal to surface integral of KDS cross B, which is equal to volume integral of JdV cross B. This is force on a current element. Similarly, if you take force between two current elements, what is force between two current elements called? What is the term that we use to represent force between two current elements? Anyone? The total force between two current elements is given by mu naught I1 I2 by 2 pi r. Mu naught I1 I2 by 2 pi r. This is again a very important topic. On forces. And also, especially when you're talking about this Coulomb's law, at times you will encounter a condition where there are two charges are not available. In Coulomb's law, when only one charge is available, and that charge let be some plus q, is the distance of d from a conducting ground plane. And in these situations, we use a method called method of images. What we do in method of images is we remove this ground plane and at some equal distance d again, at some equal distance d again, we take the same charge of magnitude q but opposite polarity. Now you have two charges separated by a total distance of 2d. Now you apply the Coulomb's law. It's also very important, especially for your gate exam. It's a very important concept, and it is called as method of images. Any doubts so far? Kindly respond in the chat box. Okay. So now, no. This is on revision question. Direction of magnetic field. Sorry. This is a revision question. Direction of electric field related to Coulomb's law. We know E is always in radial direction. Yeah. Apply that concept here and try to find the answer. Please type your answer in the chat box. Please find out and type your answer in the chat box. Yeah. How to find this? A positive charge a positive charge of plus q coulombs is located at a of 0 comma 0 comma 3. Yeah. And a negative charge of minus q coulomb is located at 0 comma 0 comma minus 3. I want to find the electric field intensity at c of 4 comma 0 comma 0. It is a of 0 comma 0 comma 3, that is it is on z axis. It is on negative z axis. Clearly this is on the x axis, 4 comma 0 comma 0. Now you know positive charge is source of electric field. One second. Okay. We know positive charge is source of electric field. So electric field will move radially outward like this. Negative charge, sink of electric field, so it will move in this way. According to parallelogram law, A and B are two arms of a parallelogram. The resultant is a diagonal. Resultant will be the diagonal. This is the direction of the resultant electric field, which is the diagonal, which is the negative z direction. Option D will be your answer. Now, you can see here there is a positive charge and here is a negative charge. And we got option D is the answer. This is case 1 given the question. Charge 1 is plus Q, charge Q2 is minus Q. Resultant direction is negative z direction. Take case 2. If I consider both the charges to be positive, can someone now tell me what is the resultant direction? Yeah, if both are positive charges, this will go radially outward like this. If A and B are two arms of this parallelogram, resultant will be along the diagonal, that is positive x. Yeah, very good, Bhumika. If I take case 3, this is negative and this is positive. Can you tell me what the resultant now? Yeah, if I reverse the polarity, direction will also reverse. Simple. Minus q plus q. Direction also reverse. Instead of minus z, now it will become plus z. If both are negative, now polarity and both the charges are reversed, direction reversed. Polarity and both the charges are reversed. Direction will reverse. Both are negative, you can see in this way. So this is the question. Yeah, this is a question related to the direction of electric field. Okay. Yeah. Is this clear? Yeah. Good. Now we'll discuss a question on force between point charges. Can someone tell me the answer for this? One second. Yeah. Okay. What's the answer? 0.009. 9 millinewton. 9 millinewton. Because force is Q1 Q2 by 4 pi epsilon naught R square. Given each charge 1 nanocoulomb, separation between them is 1 mm, 10 power minus 3 meter. Don't you substitute, epsilon naught is 8.854 into 10 power minus 12 farad per meter. 10 power minus 9 by 36 pi farad per meter. This gives you 1 by 4 pi epsilon naught is 1 by 4 pi into 10 power minus 9 by 36 pi. 9 into 10 power 9 meter per farad. This gives you Q1 is 10 power minus 9, 1 nanocoulomb. Q2 is 1 nanocoulomb. 1 by 4 pi epsilon naught is 9 into 10 power 9. R square, R is 10 power minus 3 whole square. You go of force is 9 into 10 power minus 9 into 10 power plus 6. 9 into 10 power minus 3 Newton. Point 009 Newton. Okay. That simple question on force. Ah. Yeah. Can you solve this? Can people solve this? Yeah. What's the answer here? Just a second. Okay. This is 5 grams. Sorry. Two small diameter, mass is 5 gram. Dielectric balls, 5 gram is 5 into 10 power minus 3 kilogram. Because I need to write in the SI units. Okay. Yeah. Correct. Chandrasekhar. Can slide freely on a vertical non-conducting thread. Each carries a negative charge minus 2 microcoulomb. the lower ball is restrained from moving, then separation between the two balls will be given by. This is force F is equal to mg. G is force due to gravity. It is 9.8 meter per second square. If I equate this to electric force F, Q1 Q2 by 4 pi epsilon naught r square, m is 5 into 10 power minus 3 into 9.8. It's minus 2 into 10 power minus 6, minus 2 into 10 power minus 6, 9 into 10 power 9 by r square, 49 into 10 power minus 3. That's 4 into 10 power minus 12, 9 into 10 power 9, 49 into 10 power minus 3 is r square. R square is 36 by 49. R is 6 by 7, 0.857 meter. In millimeter, it is 857 mm. Clear? Okay. How about this question? Yeah, do it. What will be the answer for this? Yeah. Tanushree, are you talking something? You're in mute. You're in mute, Tanushree. I think you're talking something. You can please unmute and talk. No, that's the wrong answer, Bhumika. Okay, okay, Tanushree. What is the answer here? Consider an electron consider an electron, a neutron, and a proton initially at rest and placed along a straight line such that the neutron is exactly at the center of the line joining electron and proton. At time t is equal to 0, the particles are released. Now they can go any way they want. But we took an assumption. But are constrained to move along the straight line itself, which is not the general case. In general, they can move any way they want. In this case, which of these will collide first? Now you know electron is negative charge, proton is positive charge. You know, unlike charges attract, so they move towards each other, and this fellow is exactly at the center. So most probably all must collide together. That's the logic. But my question is that correct? Anyone? Is that logic correct? That's the most probable answer. That everyone will collide together. But is that correct answer I'm asking? Anyone? This would be a correct answer if mass of electron is equal to mass of proton. But you know, mass of electron is 9.11 into 10 power minus 31 kg, which is approximately 10 times 10 power minus 31 kg, which is approximately 10 power minus 30 kg. And anyone, what is mass of proton? We know proton is a heavier object. 1.67 into 10 power minus 27 kg, approximately 1 times 10 power minus 27 kg, which is 10 power minus 27 kg. So this is like 10 power minus 27 is 1000 times 10 power minus 30. Okay, that means this is a lighter object. This is a heavier object. I mean the reverse way around. I mean the reverse way around. This is the heavier object. This is the lighter object. So, you know, mass of electron is very, very small, approximately 1000 times. And precisely, mass of proton is 1,836 times, beg your pardon, 1,836 times the mass of electron. Okay. So it's a very heavier object. In other words, mobility of electron is high, mobility of proton is low. So this fellow will move slowly. This fellow will move fastly. So electron and neutron will collide first. Is that clear? Okay. This is topic on method of images. Topic on method of images. Try and solve this. Check your answer once again, Bhumika. Yeah, correct. Rakesh. Chandra Hari. Yeah, correct. So, what's the question here? The force on a point charge plus Q kept at a distance D, an infinite grounded metal plate in a medium with permittivity epsilon is, again, you have only one charge separated by distance D from a conducting grounded plate. Then you take it equidistance D, you take one more charge minus Q. No, there are two charges plus Q and minus Q separated by distance 2D. Plus Q and minus Q separated by 2D. Now the total force is Q into minus Q by 4 pi epsilon medium. Distance is 2D whole square. I want the magnitude of force, therefore it is Q square by 16 pi epsilon D square. They're opposite charges, so they move towards this plate. So towards the plate. Therefore, option C is the answer. Is this clear? Okay. Any doubts here? This is one more question. Method of images. Solve this one. Anyone? What is the answer? Okay. So how to solve this? A positive charge a positive charge 1 nanocoulomb is placed at 0 comma 0 comma point 2 of 1 nanocoulomb is placed at 0 comma 0 comma point 2. Let be a. All dimensions are in meter. Consider the xy plane to be the grounded plane. Consider the xy plane. This is the xy plane. Consider this to be the conducting ground plane. The z component of electric field the z component of electric field at 0 comma 0 comma point 1 is closest to. So again, the case of method of images, only one charge is given separated by some distance d from a conducting infinite ground plane. Now, so we apply method of images. We take one more charge B of 0 comma 0 comma minus zero point 0.2. Okay. Zero comma 0 comma minus zero point 0.2. Now, if you see here, there are two charges. I consider this to be minus 1 nanocoulomb. And I want to find the Z component of electric field at 0 comma 0 comma 0.1. So at this point, I want to find the electric field, which is E is equal to E1 plus E2. That is E is Q1 by 4 pi epsilon naught R1 cube into R1 plus Q2 by 4 pi epsilon naught. Remember, this is Q1 here. This is Q2 by 4 pi epsilon naught R2 cube into R2. So if I want to find R1, this is R1 and this is R2. So if I want to find R1, then this is X1, Y1, Z1 source point, destination point X2, Y2, Z2. Then this will be X2 minus X1 AX plus Y2 minus Y1 AY plus Z2 minus Z1 AZ minus 0.1 AZ. Similarly, mod of R1 which will be 0.1. R2 is, this will become X1, Y1, Z1. So 0.1 minus of minus 0.2, 0.3 AZ. Mod of R2 is 0.3. E is Q1 1 nanocoulomb. 1 by 4 pi epsilon naught 9 into 10 power 9 R1 0.1 whole cube into R1 minus 0.1 AZ. 1.1 get cancelled. Plus Q2 is minus 1 nanocoulomb. 9 into 10 power 9 R2 0.3 AZ by 0.3 whole cube. This is this will be E is equal to this fellow get cancelled off minus 9 AZ by 1 by 10 whole square. It's a minus here, remember. Minus 9 by 3 by 10 whole square of AZ is minus 900 AZ minus 100 AZ is minus 1000 AZ. So the Z component of electric field will be closest to minus 1000 volt per meter. The one which is very close to minus 1000 is minus 999.09. Refer. Option D is the answer. Yeah. Is this clear? Yeah. Everyone, is it clear? Okay. Now try and solve this one, which is similar to the previous one. Anyone got the answer? Please type your answer in the chat box. Everyone, please try. Yes, Bhumika. Yeah, correct answer, Bhumika. Chandrahari, correct answer. How to do this? A perfectly conducting metal plate in the XY plane in the right-handed coordinate system is considered a charge of q, where q is 32 pi epsilon naught root 2 coulomb, is placed in the coordinate 0 comma 0 comma 2. If epsilon naught is the permittivity of free space and ax, ay, az are the unit vectors along x, y and z respectively, the coordinate root 2 comma 0, which implies xy plane. Find the electric field vector at this point. Again, this is method of images. So you remove the infinitely conducting grounded metal plate and you apply method of images. We apply method of images. Method of images, the equidistant, that is at 0 comma 0 comma minus 0.2, we take a charge q, but now with opposite polarity. It's asking us to find the electric field at this point. Again, the electric field at that point, E is E1 plus E2. E is Q1 by 4 pi epsilon naught R1 cube into R1 plus Q2 by 4 pi epsilon naught R2 cube into R2. So this is the source point X1, Y1, Z1. This is destination point X2, Y2, Z2. R1 is the distance between this source point and the destination point given by R1 is X2 minus X1 AX root 2 AX plus Y2 minus Y1 AY root 2 AY minus 2 AZ, that's R1. Similarly, mod of R1, which is under root of 2 plus 4, that's root 8, which is 2 root 2. Similarly, R2, this is X1, Y1, Z1, and this is X2, Y2, Z2. R2 is root 2 AX plus root 2 AY. Yeah, correct. This is minus 2. Yeah. Yeah. There is Z2 minus Z1 AZ plus 2 AZ. Mod of R2, which is R2, under root of 8, which is 2 root 2. Substituting is charge is Q here. So let it be Q. 9 into 10 power 9 R1 root 2 ax plus root 2 ay minus 2 az r1 cube, that is root 8 whole cube, that's 8 root 8, 8 into 2 root 2, which is 16 root 2. 16 root 2 plus q2, that's plus minus q, 9 into 10 power 9, r2 root 2 ax plus root 2 ay plus 2 az by 16 root 2. Now taking q, 9 into 10 power 9 by 16 root 2 common, root 2 ax root 2 ay minus 2 az minus root 2 x minus root 2 ay minus 2 az, denominator 16 root 2 I took common, dig off, which is q into 9 into 10 power 9 minus 4 az by 16 root 2. Okay. Now once you substitute this value, this is minus 4q az by 16 root 2, 9 into 10 power 9 is 4 pi epsilon naught for one time. This of is minus q az by 16 root 2 pi epsilon naught. Q is 32 pi epsilon naught root 2 minus 32 pi epsilon naught root 2 by 16 pi epsilon naught root 2 az. Okay. Is there a term that we are missing? Is there any other term that we are missing? Check out. All the terms covered? Check once. Is there any other term that we are missing? Just check once. No, I'm right. Okay. So this will be minus 2sz. Verified, everyone? Chandahari verified. Bhumika, did you verify? Yeah, please let me know. Bhumika verified. What's the answer that you got then? Okay. No. Let us solve this one. Two identical wires, two identical copper wires, W1 and W2 are placed parallel as shown in the figure, carry current I and 2I respectively in opposite directions. If two wires are separated by a distance of 4r, then the magnitude of the magnetic field B between the wires at a distance of r from W1 is. So this is on the Biot-Savart law, the case of infinite line. You know, in the parallel wire case, if you take two parallel wires carrying current I, what is the relation? Two parallel wires carrying some current I in the same direction. According to Faraday's right hand thumb rule, the right hand thumb indicates the direction of flow of current, fingers encircling indicates magnetic field. So, magnetic field will move in this way. Similarly, for the next line, the magnetic field will move in this way. So, in a parallel wire, when the current is in same direction, there will be a cancellation here in the field. And you can see force of lines which are attractive. Force of lines are attractive, but field will cancel. Current is in same direction in parallel wire. Force is attractive, but field between them will cancel. Similarly, when the current is in opposite direction, then force is repulsive and field will add. Now, in this case, current is in opposite direction. Whenever current is in opposite direction, field is adding. So, from this I can say B is equal to B1 plus B2. B is mu naught H1, B2 is mu naught H1, magnetic field H1 is infinite line concept. I by 2 pi r distance into direction A phi. But anyways, I am not concerned about the direction. So B is mu naught I by 2 pi r plus mu naught H2 is current is 2I by 2 pi. Distance is 3r into a5. 2I by 6 pi r. Now once I multiply to make denominator equal, B is 3 mu naught I by 6 pi r plus 2 mu naught I by 6 pi r. You must be very careful because current is in opposite direction, force is repulsive, fields will add. If you take the other way, you get 3 mu naught I by 6 pi r minus 2 mu naught I by 6 pi r, which is mu naught I by 6 pi r, which is available option here, which is very, very dangerous. You may do it wrong. So answer is 5 mu naught I by 6 pi r. So option D will be the answer. Is that clear? That's why when you are doing this with this parallel wire, you should be very, very careful. Any doubts here? This is multiple concept, infinite line and parallel wire together. Well, Raj, Bhumika, any doubts? Okay. So that's how we try to solve the parallel wire one. Now, this is how you try to find magnetic field B, center of any polygon. He's asking find the magnitude of magnetic flux density B in microtesla at the center of the loop of wire wound as a regular hexagon of side length 1 meter, carries current of 1 ampere, placed in vacuum. So I want to find B here at the center. Now you need to take the finite line concept. The point of evaluation is at the center of those points. So here very clearly the formula that will be useful is H is equal to I by 4 pi rho cos alpha 1 plus cos alpha 2 of A5. I get this at the center. So if I want to find this, this is rho radial distance. This is alpha 1. This is alpha 2, equilateral triangle, projecting 60 and 60. Here alpha 1 is 60 degrees. Alpha 2 is 60 degrees. H is I current 1 amp by 4 pi, rho we don't know. Cos 60 plus cos 60, 1 by 2 plus 1 by 2 into A5. Anyways, only I want to find the magnitude, so neglect A5. H is 1 by 4 pi rho. So I should find this rho. This is 1. This is also 1. And this is 60 here. This is the hypotenuse. This is adjacent 1 by 2, 1 by 2. So you apply tan 60, opposite by adjacent, rho by 1 by 2. Tan 60 is root 3. Root 3 by 2 is equal to rho. Or you can take hypotenuse square, which is 1, is rho square plus 1 by 2 whole square. Rho square is 1 minus 1 by 4. 3 by 4. Rho is root 3 by 2. You can simply apply Pythagoras. It's up to you. So H is 1 by 4 pi root 3 by 2, 1 by 2 root 3 pi. But I want B. B is mu naught H. 4 pi into 10 power minus 7 by 2 root 3 pi. Pi and pi get cancelled. This is 2 by root 3 into 10 power minus 7. I want in micro. Answer is in micro Teslas. 2 by 1.732 into 10 power minus 7. 2 by 17.32 micro. That's 0.115 micro Tesla. So most of you will go for C because that is in the option. But sadly, this is only for one line. There are 6 such lines here, six such sides here, and current is in opposite direction. Force is repulsive. Field will add every time. So I need to add this 6 times for the total value. 6 into 0.115 microtesla, which is 0.69 microtesla. So option D is the answer. Yeah, is that clear? Everyone, is that clear? Okay, there is a shortcut method for this. How to do the shortcut for this is, the shortcut method, you can find H at the center of any polygon is given by H is equal to Ni by pi L tan 180 by N into sin 180 by N. This gives you the absolute value of H at the center of any polygon. Here it is hexagon, N is 6, current is 1 amp, pi, length on each side is 1, tan 180 by 6, tan 30 into sin 30. That's 6 by pi, 1 by root 3 into 1 by 2. This is root 3 by pi. Ampere per meter. That's H value. B is mu naught H. This is total H value at the center. 4 × 10⁻⁻7 by root 3 pi. This will be 0.69 microtesla again. With this formula, you can do it very fast. Just as formula substitution, we can do it within a minute. Under a minute, we can finish it. Less than a minute, you can easily finish it. Okay. So try this. This is a question based on direction of magnetic field. We know direction of electric field is always radial, whereas direction of magnetic field is current cross radial. I can say it will be perpendicular to both current and radial direction. So use this concept and try to solve. How to solve this? See, you consider this scenario. This is X here. If you see this current element, it is carrying a current of 1 amp in X direction. So current is in X direction. You know, direction of magnetic field is current cross radial. Here current is in X direction, AX, cross the radial distance between this current element here and this point of evaluation because he's asking us to find at the origin here. This is the point of evaluation. So this is the radial distance. This is along y-axis. This will be AY. This will be minus AY. So radial distance is along minus AY. AX cross AY is AZ. AX cross minus AY is minus AZ. Neglecting the polarity. Direction of Z magnetic field is along Z direction for this component. Similarly, if you do for this component, here current is along the y direction, cross radial is this. This is along Z, AZ. This is the reverse of it, which is along minus AZ. This will be AY cross minus AZ. No, AY cross AZ is AX. AY cross minus AZ is minus AX. Neglecting the polarity here because I want X. Which direction? That's it. It can be positive or negative. Here you will have X direction component. Here you have Z direction component. So put together, you have components of X and Z which are non-zero. That is option D is the answer. Is that clear? On Sunday, we'll have our next class. We'll have our next revision class on Sunday. We'll meet on Sunday, sharp 9 a.m. Thank you.